So section 5.4, question number 10, like we can reduce fractions and we can reduce things in algebra, we can do some fancy trig algebra to reduce trigonometric expressions. And to do that, we need to know some identities. So I just want to remind you about some trig identities we've learned so far. And we're going to keep learning them. Most days we'll learn a new one. We know that the Pythagorean theorem, sine squared of an angle plus the cosine squared of the angle equals 1. We know that the tangent of theta is sine over cosine. Got to have angles. No angles, no trig. We know that the secant of an angle is 1 over the cosine of the same angle. We know the cosecant of an angle is equal to 1 over the sine of the angle. We know the cotangent. So you should definitely have a separate page in your notebook where every time you learn a new identity, you write it down. So you'll have a page to reference that has all the identities you need. Oops, carried away there. Is the reciprocal of the tangent. So that would be cosine of theta divided by the sine of theta. And we learned a couple of other versions of that identity right there involving the other 4 trig functions. So one of them is 1 plus the cotangent of theta is equal to the cosecant of theta. And then the, let's see, 1 plus, squared, Pythagorean. And then 1 plus the tangent squared of theta is equal to the secant squared of theta. Do we have any other ones to date? I think those are the big ones we have so far. All right, so my usual reaction is when I see things like cosecants and tangents, I want to rewrite them as sines and cosines. So for this particular problem, I'm thinking, all right, cosecant, I'm going to rewrite it as a sine, and the cotangent there, oops, I didn't want to circle that there, is cosine over sine. So I'm going to use those 2 identities to rewrite it and see how things clean up. So I got my big fraction bar. I'm leaving the sine alone for now. And they're using a t instead of a theta. That's okay. Let's keep that in mind when we write our answer. Cosecant is 1 over the sine of whatever angle I started with. In this case, it's t. And cotangent is cosine over sine. And this time it's t, not theta. Keep that in mind. So I have a complex fraction here. There are 2 techniques for dealing with complex fractions you learned back in some previous math course. One is to clean up the numerator, clean up the denominator, and multiply by the reciprocal. The other way is to multiply top and bottom by something to clear denominators. So I'm going to do that. A little different than the approach I took last time. So I'm going to multiply this numerator here by the sine of t, because that's the denominator there. And I have the same denominator down here, which is fortunate. So my common denominator is sine of t, right? So I'm multiplying by sine of t over sine of t, which means I'm multiplying by 1, but in a fancy way. Distribute through the top, distribute into the bottom. So sine of t over sine of t is 1, minus sine of t times sine of t is the sine of t squared. In the denominator, multiplying by the sine cancels with the denominator, leaving just the cosine of t. Now, I see a sine squared and I see a 1, and I'm thinking, ooh, that looks something like that right there. So if I just rewrite that right there, if I subtract that sine squared to the other side, then I'm going to get the cosine squared of t is equal to 1 minus the sine squared. Ah, look at that. That's beautiful. That is my numerator right here. So I've just discovered my numerator is really cosine squared Oops, and I'm using t's, not thetas. Divided by the cosine of t. So if I have a square of something divided by itself, one of those cancels. So that leaves just a cosine in the numerator. That cleaned up quite a bit. So was I able to write it as a single trig function with no fractions? The answer is yeah. I did. How could I check that's right? Well, I could pick an angle for theta or t and see if it works. So let's check on a calculator. And let's see. I think GeoGebra knows cosecant. Let's find out. Cosecant, yes, it does. And let's just pick some arbitrary angle. I am going to be 52 this year, so let's use 52 minus the, oops, I need a fraction for this whole thing. So I need a parentheses and then minus the sine of 52 and then divide the parentheses by, what was it, cotangent? I need to double check that. Oops, you're over here. Yeah, cotangent. So I picked some arbitrary angle and I claim that that should be the same as the cosine. So let's ask, what if I take the cosine and, oh, it defaulted to degrees. That's interesting, not what I expected. 52, I get the exact same number. Does Desmos recognize cosecant and cotangent? I do not remember. Let's see. Cosecant of 52, hey, it does. And let's say I want parentheses around that. Minus the sine of 52. And it's not clear whether I have radians or degrees here. Then divide all of that by the cotangent. Looks like it recognizes it, of 52. Is that the same thing as the cosine of 52? And it is, but that looks different than what GeoGebra told me. Yeah, so GeoGebra defaulted to degrees. That's surprising. Desmos defaulted to radians. Notice we have a different final answer here, but they're the same final answer. So what was my point? My point is, how did I check something like that? And we think that that crazy fraction up there can be reduced to the cosine of the same angle for any angle. So I just picked some arbitrary angle and said, hey, does the first thing really match the second? The answer is yeah. So before I hit submit, I know I'm right. Ta-da. That was exciting.